This program is a co-production of Access Alberta and the Southern Alberta Institute of Technology. Fly forming is a systematic way of constructing suspended slabs of concrete to make the floors of buildings. Fly forms are especially efficient in high-rise construction because there is a demand for repeated building of similar-sized floor slabs. Cranes lift these forms from one floor to another and fly them to their next location. This is why they are called fly forms. In the past, when materials and labor were relatively cheap, architects and engineers were not too concerned with designing buildings for efficient techniques of construction. Also, concrete technology was still at an early stage of development. Techniques for reinforcing concrete were still fairly primitive. Equipment for hoisting materials and ways of transporting concrete were still in their infancy. This diagram illustrates the significant reduction in time taken to complete construction of buildings. The invention of plywood and the development of large-scale, machine-handled forms played a major part in reducing the time taken to complete the job. Rapid post-war urbanization drastically increased the demand for downtown land, and high-rise buildings became the predominant style of architecture. Modern concrete technology uses new admixtures for greater strength. Special mixes can now be produced to meet specialized job requirements. Reinforcing methods now utilize high-tensile steel to enhance the value of concrete as the major building material. The importance of forming systems can be appreciated when we know that 30 to 60% of the cost of building the shell structure is the cost of form work. The development of climbing cranes and advanced techniques for moving concrete have allowed the large-scale use of modular forms, which can be reused many times. Movement of large prefabricated forms allows for rapid, low-cost construction with minimum manpower requirements. This fly form is very similar to an ordinary table. Each fly form has these major parts: a deck or tabletop, which forms the floor; the framework or legs, which supports the deck and the weight of the concrete upon it. Notice that the legs are adjustable so that an exact slab height can be set. In this typical fly-forming operation, the first step is to attach the crane cables to the outer edge of the form. Then the hydraulic cradle is adjusted to take the weight of the form. The legs are then telescoped and pinned. The front legs are then folded so that the form can be lowered sufficiently to be flown out below the spandrel beam. The back legs are then lowered into specially constructed dollies. These dollies allow the form to be wheeled out with minimum effort. The hydraulic cradle is then moved ahead to allow the form to be dollied out so that the crane pick holes are exposed. The form is now supported at the front by the hydraulic cradle so that the crane cables can be detached and repositioned through the form surface. The crane cables are firmly attached to the main structural beams of the fly form. The fly form is now under the control of the crane operator and the stripping crew. The fly form is now skidded out to allow the back crane cables to be attached. The crane cables are now adjusted by a winch to ensure that the form is level and stable. This is essential because a fly form that is not balanced properly can be dangerous. Another safety feature is the attachment of a tag line, controlled from the building because the crane operator has no means of stopping the fly form from spinning. The screw jacks are repositioned to an approximate height before the legs are telescoped down. Once the back legs are securely pinned, the front legs can be folded down and braced. The front legs are designed to be folded so that they can clear the spandrel beam. The fly form is positioned over predetermined guide marks, and the crane cables can now be detached. Now that this fly form is in position, the entire process is repeated until every form has been relocated. This is one type of forming system. There are many others, but the general procedure is similar. We can now examine each part of the fly form in more detail. The plywood decking must be of top quality so that it can be reused many times without being damaged. It is more economical in the long run to invest in top quality plywood decking because of the very heavy wear and tear on the form. Notice that the deck is longer than the slab. This is to allow for a walkway and room to store construction materials. The deck is supported by a joist system, not unlike a residential floor joist layout. The size and spacing of the joists is designed for the thickness of the plywood and the load of the concrete slab. Supporting these joists are two or more trusses or beams which run the length of the fly form. Spacing of the trusses is designed by the engineer to minimize bending of the deck under the weight of concrete. This bending under load is known as deflection. Deflection can be demonstrated in this model where the red bricks simulate the concrete slab. When they are fully supported, the slab is perfectly horizontal. The supporting blocks represent the trusses. When the two trusses are positioned at the very end of the form, severe deflection can be noticed. This setup is a simple span and is the weakest type of support. When the supports are moved in from the ends, a cantilever span is created. Notice that there is now much more support, but there is still a slight deflection in the center. As the supports are moved further in towards the center of the form, the cantilever portion counteracts the deflection in the center of the span. Moving the supports still further in towards the center creates excessive deflection on the outer edges of the form. Again, further inward movement of the trusses causes very extreme deflection at the edges of the form. Notice that the cantilevered portion of this form is approximately 1/4 to 1/3 the distance between the trusses. All fly forms have adjustable feet for setting exact heights and for ease of lowering and stripping. Generally, a screw type of adjustment is used. Fly forms have small squares removed from the form surface so that crane cables can be attached easily. These pick points must be symmetrically located so that the form is balanced when it is flown. Before the rebar is positioned, the pick points have to be patched to ensure an even surface. Placing filler strips between the fly forms is the final stage before placing the rebar and concrete. It is a requirement of the Occupational Health and Safety Act that each slab be completely surrounded by a protective handrail. Each fly form has a built-in handrail section that always travels with the form. Notice again that workers always use a lifeline in this type of situation. Fly forms may also be equipped with built-in hoarding panels that allow for the floor below the slab to be heated when required. Hoarding panels also travel with the form. Alternatively, tarpaulins may be installed around the slab. Having looked at the operation of one fly form system and examined detailed aspects of fly forming, this sequence illustrates a different operational system. The fly form is dropped by adjusting the leveling feet. Skidding out allows the two front pick points to be exposed. Crane cables are then attached through the form surface to the main structural trusses of the form. Now the form can be skidded out even further to expose the rear pick points. Once the rear cables are attached, the form can be flown out and raised up to its new position. Once the fly form is removed, reshoring takes place immediately, so the weight of the slab is distributed evenly. The fly form is then guided into its new position, ready for leveling and filling in between the column line. Fly forming is a systematic way of forming large floor slab areas in high-rise construction. Like gang forming, it uses modular, reusable panels pre-assembled to meet the job requirements.